In the previous part of this tutorial series, we created blank fragments. We can navigate between them using the navigation architecture component library like this. So here we are on the current weather fragment, then we can go to future list weather fragment and also to settings fragment. But all of those fragments to which we can navigate are completely blank and basically unusable. In this tutorial, we will add some actual functionality to this Android Forecast MVVM app, namely the ability to fetch weather from an API. This means that in this part you are going to learn how to use Retrofit together with Gson library to fetch and parse JSON data from an API. The API we are gonna be using is Apixu.com, which is a weather API offering a generous, and I mean a really generous, free plan. Even though we are going to be using this Apixu API, you can apply what you learn here to any other API you desire, so if there are any problems with Apixu in the future, we will be able to switch to a different API really easily. Hello, welcome to ResoCoder. So first, let's go over to Apixu.com, and the link is also in the video description. And over here, you want to sign up, but I already have an account, so I am just gonna log in. Once you are logged in, you wanna go over to Dashboard, and in Dashboard, you can see that our current plan is the free plan. And if we click on Change Plan, you can see that when we are using the free tier, we have 10,000 API calls per month. So we can fetch weather data 10,000 times per month, which is quite enough. So let's go back to Dashboard, and you can also see that we have an API key associated with our account. So this is the API key over here, 89 and something. We are going to copy this API key later, and please copy your own API keys and not mine, but even if you copy mine, that doesn't matter, but you should really create your own account so that my account's API usage doesn't get too bloated. Now, actually, we want to copy this API key, so just Control-C to copy it, and now let's go over to the Interactive tab over here. And we can paste our API key to this field, make sure there are no spaces, and we can query for current weather, because in this tutorial we are going to be implementing the current weather, and then later we will also implement fetching the forecasts, but for now let's just focus on current weather. So as the query string, we want to put some city, so for example London. And now let's hit show response. And here is our response. And this response is in the JSON format. And a bit up, we have actually the call URL. So if we copy this URL and open it in a new tab, we're gonna get exactly the same JSON as we have gotten over here. So actually, this is the URL that we are going to operate with in our app through the Retrofit library. If I make this bigger so you can actually see something on YouTube, you will see that we get two objects, two JSON objects. One of them is location and another one is current. We are going to get to location later because we are actually going to want to operate with location because we want to show the currently fetched location and so on in the toolbar. As you can see in the finished app, over here is Austin and today. So this is from the location object. But for now, let's ignore this location object. But we have a much more important object, and that is the actual current weather. Here we have the last updated time. This is not really important for us, but we have temperature in Celsius and also in Fahrenheit. We have weather condition. We also have the weather icon as a part of the condition sub-object. Then we have the wind speed, we have wind direction, right? North, and also pressure, precipitation, humidity, clouds, if it's cloudy or not. Currently it's not cloudy in London, it seems so. Then we also have the feels like temperature, also in Celsius and Fahrenheit, and we also have visibility. So there is really a lot. So we have all of this data, but we have it in a JSON format, And as you can probably imagine, this JSON format doesn't do us any good when we are working with Android apps. Because of this, we need to convert this JSON to some objects which Kotlin language can operate with. And for that, we are going to use the library Gson, which is a library which can parse JSON into some real objects which we can operate through Java or Kotlin. So let's go to Android Studio and let's open app, Java, and our package, and then data. And in the data package, we want to create the classes which are gonna be representing the JSON that we get from the API. And we could do this by hand, but that would be pretty exhausting because for every field that we get from JSON, so here we have it, here is field temperature C, temperature F is day, and for each and every field that you see here, we would need to create an appropriate property in our Kotlin classes. And that is pretty exhausting, but thankfully we can use an Android Studio plugin which will do this for us. So first, let's copy all of the JSON, so hit Ctrl A and Ctrl C, and now we have it in our clipboard. And let's go back to Android Studio. And we are going to use an Android Studio plugin called JSON to Kotlin class. You can get it by going to File, Settings, and then Plugins, and you want to search or actually browse repositories down here, and you want to search for JSON to Kotlin class. I already have it downloaded, so you just hit install or something like that, and you will have it in your Android Studio after you restart. And once you have it, we are gonna right click on data package, and we want to hit new and Kotlin data class file from JSON. We are going to set the class name to be current weather response. And we are also going to paste the JSON that we have just copied from the browser, right? So paste all of it in here. We can also format it so we can see it more clearly. You probably cannot see it on YouTube, but it's the same JSON that we have copied previously. And also, you want to go over to settings, and you can leave this to be keywords val and non-nullable. In the annotation tab, you want to select Gson because we are using the Gson library, which we have added in the first part. Because in the first part, we added every library that we are going to be using over the course of this tutorial series. And in other, you want to make sure that you are creating annotations only when needed. So make sure that this is ticked on, and hit OK and hit make. And here are the classes which were created by this plugin. We have current weather response. So this is the root of our response because we have location and we also have current. If we go over to locations definition by hitting Ctrl B, we can see that everything is over here nicely set up. But we aren't interested in locations, so let's go over to current. And actually, before we go over there, let's rename current to say current weather entry so that the meaning of the class is more clear. So current weather entry. All right. And refactor everything. But because we changed the class's name, the name of our property has also changed. But this can be a pretty big problem because if we take a look at our JSON output, you can see that the object is named current and not current weather entry. So we somehow need to tell Gson library once it's parsing the JSON over to Kotlin objects that the property called current weather entry is corresponding with the current field in JSON. How can we do that? Well, we can use an annotation. So back in Android Studio, we can annotate the current weather entry property with @serialized name. And the serialized name will be simply current as it's in JSON response. And now the Gson library will figure everything out for us. So now let's go to the definition of current weather entry. So Ctrl B. And you can see over here that we have all of the fields here really nicely. In the later parts, we are going to mess with these fields a bit. We are going to add some annotations for the room database, and we are actually going to remove some fields which we don't need. But for now, let's not worry about any of this. We are gonna modify this class in later parts. For now, just know that we also have a nested class condition, which is also defined here. It has text, icon, and code, and that's about it. Now let's create a new interface, Apixu Weather API service. So under data, we want to create a new Kotlin interface, Apixu Weather API service. Once we have it, we are going to also create a new package under data, and it will be response. And we are going to put all of our response classes, so everything basically except for the Apixu Weather API service, we are gonna pull it over to response package. And this interface, Apixu Weather API service, will be used by the Retrofit library to fetch the data from the API. Let's go back to the browser for the last time, and let's go over to our dashboard. So go to home and my account, and dashboard. And over here, you wanna again copy this API key. And now back in Android Studio, we are going to create a new constant. So const val API key, and it's going to be equal to this as a string. I also copied the query URL so we can actually have some kind of a reference when we are creating this API service. So this is how the query URL looks like. So first up, let's create a new function for getting the current weather, and we will call this whenever we wanna get the current weather, right? So fun, get current weather. And this will be a get request, so an annotation get. And we want to get the current.json because this part, the HTTP API Apixu com v1, will be handled in a different part of code, and this query will also be handled in a different part of code. So over here, in this get annotation, we only want to specify the current.json. So let's put it over here. And over here in the parameters of this function, we want to specify these query parameters. Actually, not all of them, because the key will be handled in a different part of code, which we will get to in just a little while. But for now, we want to specify this q, and this q is a query parameter for the city. So we want to specify a city. So we want to add an annotation here. So add query, its string is q, and q stands for a location or a city. So let's put over here location, which will be of type string. And just like we have q over here, we can also have another like and then lang, for example, equals en for English. So this is language and English. So we can also have this, and because our users can be speaking some other language than English, we also want to put it as a parameter of our getCurrentWeather function. So again, query, add query, lang for language, and we're going to call this parameter language code, and it's also gonna be of type string. And the value of language code will be English, so en by default. So if we don't pass any language code to our function call, it's gonna be automatically assigned to be English. And what is this function going to return? Well, fetching data from an API which is located somewhere on a distant server takes some time. Because of this, we cannot just simply return current weather response like this, right? Because this is actually returning current weather response. But we cannot return it directly, but we need to wrap it inside a FIRT, right? So the FIRT, and its generic type is current weather response. The FIRT is a part of coroutines, and we can wait, or actually await a FIRT. So whenever we call getCurrentWeather, after the call we can put await, and the Kotlin compiler will handle everything asynchronously for us, and once the hardware response is ready, we can start working with it. The FIRT is part of the Kotlin's Coroutines, and if you want to learn more about Kotlin's Coroutines, I have a separate tutorial about them, so you can check it out by clicking on the card in the corner. But having just an interface is not enough. We need to have some kind of a class which will be operating with this interface, and that class will be actually fetching the data from the API. For that, we are going to create a companion object for this interface, and companion objects are basically like static methods. And this companion object will have just one function, and it will be operator function, so operator fun, and its name is Invoke, and it's going to return Apixu Weather API service, so this precise interface here. And it actually doesn't need to be operator fun invoke, it's just here because the syntax for invoke is really nice. For example, if this wasn't an operator fun invoke, but it was just fun create, for example, we would need to call Apixu Weather API service.create, right? And that's how we would call the create function. But because this function is called invoke, we can call it by simply writing Apixu Weather API service and then 2 parentheses, and this is the same as calling .invoke. So operator function invoke is just really nice syntactically, because we can call it like this, as if we were instantiating a class. Alright, enough about invoke, and now let's look at how we can actually put this API key into every single call of the Apixu Weather API service. We could also hardcode this API key over to this call, so just putting add query, right? Add query and then key, and then the value of the key as the parameter. But this is not a good practice. When some value is passed to the query string every single time that it's called, it's better to pass it in there with a request interceptor. So over in Invoke, let's create a new val request interceptor, and it's gonna be equal to interceptor. And this is an anonymous class with only one function, so we can use the lambda syntax like we are doing now. And this will pass us a chain, so chain. And now we want to add this key, this API key, as a query parameter. So we want to add it to the URL, which is currently intercepted, because request interceptor intercepts requests, how else? So we want to get val URL, and it's going to be equal to chain.request. And on this request, we want to get URL. Then we want to have a new builder, because we are going to use this builder to add a query parameter. And this query parameter's name will be key, because as you can see here, its name is key. And the actual key which we want to pass over here is the API key, which is our constant defined above. And once we have this query parameter added to our URL, we want to call build on this new builder. Then we also want to create val request, and this is also going to be equal to chain.request. And now we want to call new builder directly on this request, and we want to set the URL to be our updated URL, because we have just added a query parameter to it. So let's add the URL and now call build. And from this interceptor lambda, from this whole lambda, we want to return, so return at interceptor chain.proceed, and we want to proceed with the request that we have created, and this request contains the updated URL, and this updated URL contains our API key. Now we actually want to add this request interceptor to a class called OKHTTP client, so that it actually intercepts every single call. So let's create val OKHTTP client, and it's gonna be equal to OKHTTP client.builder, and we want to add interceptor on this builder, and our interceptor is called request interceptor, and then we want to call build. Alright, and finally, we want to return Apixu Weather API service from this invoke function. For that, we are going to create an implementation of Apixu Weather API service through Retrofit. So we want to return retrofit.builder, and on this builder we want to set the client and also import retrofit, so Alt Enter and import. And the client will be set to OK HTTP client, which contains our interceptor here, right? Then the base URL for every single call will be this. So HTTP API Apixu.com v1, and also this slash over here. So let's copy it and paste it as our base URL. So this is the base URL of every single call that we make. And actually we can also make this HTTPS so that it's secure, but it doesn't really matter. You can leave it at HTTP2 and you will be just fine. Then, because we are using the FIRTs over here, we need to specify a call adapter factory for the retrofit library. So we want to call another function, and it's call adapter factory, add call adapter factory. And the adapter factory that we want to add is coroutine call adapter factory, and this is from a library which we have added in the previous and the first part. We also want to add converter factory because we are using Gson, so we are basically now telling the retrofit to use Gson to automatically parse the JSON string into some real Kotlin objects. So Gson converter factory .create. Finally, we want to call build, and now we want to call create, and we want to create an implementation for a class Apixu Weather API service, and we want to get a class.java from our interface. Alright, so I hope that everything is clear. You can also get the code from the link in the video description so that you can look at it in more detail when you feel like it. Alright, and now we are going to do something which you should never ever do in a real production app. And we are actually gonna fix what we are about to do in later parts, but for now, let's just have something tangible so that we can see if this Apixu Weather API service actually returns some JSON. So let's go to the UI package and weather. We want to go over to current weather fragment. And for now, we are going to skip all of the steps like view models, dependency injection, repositories and database and all of that stuff, because we are going to use our Apixu Weather API service directly from the fragment just for demonstration purposes. So over in onActivityCreated, let's create a new instance of Apixu Weather API service. So val API service is equal to Apixu Weather API service, and we can call the invoke operator function really simply here. We are going to launch a new coroutine on global scope, and this is also not how it should be done, but again, just for demonstration purposes. In later parts, we are actually not gonna be using global scope, but we are going to use a scope specific to every single fragment. But just for now, let's do it with global scope for simplicity. So we want to call global scope.launch, and we want to launch it with the main dispatcher, so dispatchers.main, because we want to be able to operate with the UI, and main dispatcher allows us to do some things with the UI in the launch coroutine scope. This is because on Android you can only update the state of the UI, so text views, image views and so on, only from the main thread. And over here we want to simply create val current weather response, and it will be equal to API service, which is our Apixu Weather API service, dot get current weather. The location will be, for example, again, London. The language code will be English, so we don't even need to specify it over here. And then we want to call await. And then we want to get TextView. And actually, in order to get it, we need to go over to res, layout and current weather fragment. And we need to add an ID to this text view, which will be add plus ID simply let's say TextView, and let's go back to current weather fragment, and we want to get the text view, and we want to set its text to be equal to current weather response dot current weather entry, and then also dot toString, obviously. So let's run our app in an emulator, and we actually get an error. So let's see what's wrong. So let's go over to logcat down here, and let's change this to error. Oh, and over here we can see fatal exception, OK HTTP dispatcher, that we are missing internet permission, and surely we are missing it. So let's go to Android manifest over here. So manifest, Android manifest, and over here let's write that uses permission, and the permission name is internet, and now we should be all good to go. So now let's run the app again. And yeah, it surely works, because over here we have, I don't know if you can see it properly, but we have current weather entry, the last updated epoch, and so on. And let's actually go back to current weather fragment, and let's not print the current weather entry, but let's print the whole current weather response so that we can see the location too, to check if we are actually really fetching for London. So let's run it again. And yes, once the app is running, we can see that the location is London, the region is City of London, and so on. Alright, so that's it for this tutorial. If you don't want to miss the future parts of this tutorial series, in which we will be implementing the UI of the current weather fragment, and also the repositories, and also the database which will cache the current weather entries, subscribe to this channel and also hit the bell button so that you get notified about all of my new videos. If this video helped you with understanding and implementing the Retrofit library, and also together with Gson and fetching weather data from some API, give this video a like and also share it. Remember that you can get the code from the link in the video description. Follow me on Instagram, Facebook and Twitter. Leave a comment if you have anything to say, if you have any suggestions or questions, and see you in the next video.